So just take a look on the board real quick. Look at that definite integral. Integral from 0 to 2 pi of x cosine x dx. The graph of it's given there. All right? We're going to get some positive area and some negative area, right? How would you actually find the antiderivative of x cosine x? Integration by parts. So that integral would require integration by parts before you could do it. Would y'all like to work through that?
Yeah.
Do you want to try it?
Yes.
Yes? Go ahead. See if you can do that one. The definite integral from 0 to 2 pi of x cosine x dx. My hint to you is do all the integration first. Get this guy first. All right, that's the first part of the problem. Then you go and plug the numbers in. All right? While you're doing it, I'm going to work it out on the board. That way I don't have to write it down. The homework? It's a lot of work, huh? You're better off for it, though. You're a better man now.
In the math world.
No, overall. Just overall. You're a better person for having done that.
You got some gray hairs now.
I know, man.
That's right.
You gotta use that, was it just for men?
Why are you 30 already have gray hairs? Like Cal too.
Yeah, Cal too.
0. I missed the minus between
All right, so y'all done? For those of you who are done, how would you find the area of each of those regions?
Restricted?
Okay, so you think you could do that? Do you think you could figure out where to restrict it?
Yeah. Yeah, you can.
Okay, so you think you can find them?
The root? Yeah.
See if you can.
Come on, Matt, you can do it.
Who's still working on this? You got a couple of people still working on this? Your Your answer should be 0, which means that the area above the x-axis in that picture is equal to the area below. It's kind of interesting because it doesn't look symmetric, right? All right, so you did your integration by parts table, figured out your antiderivative first, plus c still. Then I came over here, I said, let's throw that over here, no c, your two endpoints, plug in, you get 0. But my question now is, how could you find the area of each of those regions? So what I'd like to do is see if we can visit the concept of figuring out when x cosine x would be 0. These would correspond to the x-intercepts, right, of that function. So that's a trig equation. What makes this equation true? So you have multiplication here, right? So you can just split this up. X is 0 is one answer, and then cosine x is 0 is the other answer. And I'm only looking for solutions between 0 and 2 pi, right? So what are the only places that cosine is 0 between 0 and pi? Sorry, 0 and 2 pi. If x is pi over 2 and 3 pi over 2. Right? The only places on the cosine curve where you get 0 is at pi over 2 and 3 pi over 2. So those x-intercepts are those. So what we would need to do, if we were going to do this correctly, to try, not correctly, but in order to find the area without taking into account the negative part and not letting it cancel us out like it did, is we'd have to first do an integral that goes from 0 to where? Pi over 2 of x cosine x dx. Then we would have to do another integral that went from pi over 2 to 3 pi over 2 of x cosine x dx. And then we would have to do another integral that went from 3 pi over 2 to 2 pi of x cosine x dx. The good news is that we know the antiderivative of all these, so it's just a matter of plugging things in, right? That's all this would be. So let's do this one. The antiderivative of this one, let's call this one 1, we'll call this one 2, and we'll call this one 3. So if I do 1, it's the antiderivative, which I believe was x sine x plus cosine x. And I evaluate that, this time from 0 to pi over 2. So plug pi over 2 in first. Get pi over 2. What is sine of pi over 2? 1 plus what's cosine of pi over 2? 0. Minus, and then now I plug in 0. So 0's out here. Cosine of 0 is 1. So you get pi over 2 here minus 1. Yeah? Pi over 2 minus 1? That's the area. So if you look at that over there, that first little arc above the x-axis has an area of pi over 2 minus 1. Is this a positive or a negative number? Sure? Pi is 3.14-ish. Divide that by 2, it's a little bigger than 1. Take away 1. So that should be a little positive number there, right? Now let's do this one. Sorry, we did that one. Let's do 2. Okay? So for 2, I'll put 2 right here. For 2, it's the same antiderivative. Whoa. Sine x plus cosine x. This time pi over 2 to 3 pi over 2. So I'm going to plug in, let's see, pi over 2 in here. Didn't we just do that? What happened when we plugged pi over 2 into this? We did it right here, didn't we? We got this? Wasn't it that first piece? So it's going to be pi over 2. We know that already. This piece will be different, right? Shit, hold on. I meant it the other way around, sorry. Thank you for giving me that look. 3 pi over 2 goes in first. That one's new, okay? So what's 3 pi over 2 in here? 3 pi over 2, the sine of 3 pi over 2 is negative 1. Cosine of 3 pi over 2 is 0. Then minus, now this is the one that's pi over 2. Pardon me. I apologize. Questions on that? So this is negative 3 pi over 2 minus pi over 2, which is negative 4 pi over 2, so negative 2 pi. It's negative area, right? So we'll turn it into a positive. But just in terms of the picture, that piece that goes underneath, okay, because it's negative, because it's below the x-axis, it's negative. But if I just say, hey, what's that area? And we're just like, negative doesn't make any sense, then the answer would just be 2 pi, wouldn't it? All right, let's do the last one, 3. So we're doing x sine x plus cosine x, and evaluated at 2 pi up here and 3 pi over 2 here, right? Okay, let's do 2 pi. You get 2 pi, what's sine of 2 pi? 0. Plus, what's cosine of 2 pi? 1. Minus, now plug in 3 pi over 2, which we just did that, didn't we? What did we get when we plugged 3 pi over 2 in? We got negative 3 pi over 2? So what is that? 2 pi and 0 is gone, right? So that's 1 plus 3 pi over 2? We good? If I were to take these right now and add these all up together, I should get what?
0.
0. Let's just try it. Let's do this one with this one. Don't the ones cancel?
Yes.
What's pi over 2 plus 3 pi over 2?
2 pi.
2 pi. So I have 2 pi when I put those two together. Now I put it to this. You get 0, okay? But now if we wanted the total area and counting everything as positive, then what we would do is we take this number, change that one to a positive, and then take this number, right? So everything that's above the x-axis, you just keep the answer. Anything that's below the axis, just change the sign to positive. So if we wanted that, we could say the answer would be what? Pi over 2 minus 1 plus 2 pi this time, and then plus 1 plus 3 pi over 2. And combine anything together, what is this? 4 pi? Are you getting 4 pi? 4 pi. Bless you. Yes, you could do the absolute value. But you don't want to do the absolute value of the function inside. Just take the absolute value of the answer. Yes. All right, let's talk about some of the properties of definite integrals. The first property is that the integral from a to a of any function is 0. Does that make sense to you? Why is that 0?
It's like we're not going anywhere.
Yeah, that's right. You have a function, you're saying, okay, I want to go from here to here, and that's just a straight line. And what's the area of a line? 0. A line has 0 width, so the area should be 0, right? That makes sense then? Okay, the integral from a to b of a function is equal to negative integral from b to a. So what does that mean? If I'm trying to find this area, right, whatever this area is, it's equivalent to the negative of b to a. So that's flipping these two, right? It's like instead of integrating from here to here, we're integrating from here backwards. What happens is, you know in the formula dx, the width of the rectangle, is a positive number? If you integrate from b to a, then dx is negative. And that's what changes the sign. All right, so that's all that one's saying. This next one, what's the integral of a constant? So you have a constant function. Here's the constant function, k. That's how high it is off the ground. You integrate from a to b. You want to know this area? Well, you can do that without any calculus, can't you? You know how wide it is. It's b minus a. You know how tall it is. It's k. So it's k times b minus a. Yeah? All right. We knew this already. If you have a constant in front of the function, you can pull that out. So you can find the area with the constant in there, or you can take the constant out and multiply it at the end. Next one. If your function is positive, then the area must be positive. Do you agree with that? If your function is above the x-axis, then the answer, your area should be positive also. If the function is negative, then your area is negative. The integral is negative. If you break up a number line, then you can break up the integral. We just did this. This property 7, when we broke up between 0 and 2 pi, we broke it up into 3 different integrals. That's what that property says. You're allowed to do that.
Sometimes it's easier like that. Do you mind showing 5 and 6?
Sure. Okay, so like if your function is positive, greater than or equal to 0. So I have to draw a function that's above the x-axis. Do you agree that this function is greater than 0 or equal?
I didn't need explanation. I was just writing.
Oh, okay.
Sort of as transfer.
Oh, okay.
Yeah. Apologies. You can explain it if you like. I won't stop you.
Well, just remember, all these properties are in the book, so there's not really, I mean, you don't necessarily need to copy them down. And these notes are online?
No.
These aren't. For this one? For Riemann sums, I never put the notes on?
Your previous class ones up where, like,
I'll look.
said, but
I'll look.
I haven't seen
So if the function is above the x-axis, then the area has to be positive. If the function is below the x-axis, then your area has to be negative. 7 splits them up.
Can you say just switch it though?
If you wanted to find out like what, you're going to get a negative area.
Yeah.
Your answer is going to be right, it's just going to be negative. But if it's like negative 2 pi, the area is really 2 pi. Right? If f is even, now this is an important one. If f is an even function, then we have something nice. So first you have to remember what it means for a function to be even. Geometrically, even functions are reflections of themselves over the x-axis. Oh, sorry, I meant to say y-axis. So an even function, if I take a function and reflect it over the y-axis and it lands right on top of itself, we call that an even function. So if you ever want to integrate, notice it says there negative a to positive a, not a to b. Only negative a to positive a, then whatever this area is, and this area is, there's also another version of it over there, right? So it's just whatever this is, it's going to double. Whatever this is, it's going to double. Whatever this is, it's going to double, isn't it? So that's what that property says. If you want to integrate an even function only, from negative a to a, instead, you can just go from 0 to a, so you can just go from here to here and double the answer. Double the answer from 0 to a. Make sense?
Yeah.
That you could do that? Okay. How do you think this works for odd functions? What does an odd function look like? Sine is odd? Y'all agree sine is an odd function? Okay, so let me draw sine. It would go like, let me say from here to here. Let me just draw that much sine. If I did it here and here, it's the opposite, right? So like if I went from negative a to positive a, this area over here is negative, but on the other side it's positive. And this area here is positive, and on the other side it's negative. So what should that be? If you integrate from negative a to a of an odd function, you should get 0. That's what the next property says. If f is odd, look at that, I even used the sine function there. If f is an odd function, then the integral is 0. Now, that's great, but how can you tell if a function is even or odd just by looking at, like not looking at the graph? You can tell by looking at the graph, but if someone just gives you a function, how do you tell if it's odd or even? So let me give you an example. Is f of x equals x squared, or x cubed plus x squared, odd, even, or neither? Neither is N-E-I-T-H-E-R, not I before E, except after C. How do you check it? Here's what it means to be even. For a function to be even, here's what must happen. F of x has to be equal to f of negative x. Which means that if you plug x into it, you get the same thing as plugging negative x in. So if I plug 2 in, I should get the same answer if I plug in negative 2. To be odd, when I plug a negative in, I shouldn't get just the function, because then it would be even, right? I should get the opposite. And if what? Then, yeah, then neither one of these would hold.
You would just get like a completely
Yeah.
different answer on the side.
Let's check this. Let's see what happens. What is f of negative x right now? If I take a negative number and plug it in here, what happens if I take a negative number and cube it? It's going to be negative x cubed, right?
No.
Agreed?
Yeah,
Like if I
I'd say it's
take
not.
negative 2 and cube it, I'm going to get 2 cubed but negative, right? Negative 8. Now what happens if I plug in a negative number and square it? It's positive, so that still stays the same. Okay, so first, this is the standard way of checking. You first plug a negative in, see what happens. Then, next to this, just tell me what negative f of x is. So just change the signs of everything. So this is negative x cubed and minus x squared. And now what we're going to do is check, are any of these equal to each other? Is this equal to this? Are these the same?
Yes.
They are?
No.
No. Look, if you plug in 1 here, what do you get? 1 plus 1, right? You get 2. If I plug in 1 here, I get 1, I get 0, right? These aren't the same? So it's not even. Is it odd? So I have to check, are these two the same? Almost, but that minus, right? Those two aren't the same. It's not odd either. Therefore, it's neither. So given a function, it's either odd, even, or neither. Questions? If I change this to a 6, what does this do? When you take a negative number and raise it to the 6th power, it doesn't matter, right? It's going to stay. And then here, stay. If I change the signs, it's negative, this. So you check, are these two the same? Yes, it's an even function. These two are not the same, right? Okay. How are we doing on time? Oh, we got plenty of time. Plenty of time. So one of the more profound questions, go ahead, man. $5.
Oh, that's precious.
I can't do that, actually. I can't gamble in class on camera. So I withdraw that statement. But go ahead. I want to see if you're going to make it or not.
Easy buy.
Come on. Oh, you got rejected by the pillar, which has been there since the building was put up.
It's the win.
All right. Okay, so, one of the more profound questions that we asked as we were progressing mentally as a species is, we have a really easy way of finding the area of rectangles. It made sense to us to define it as length times width. The integral is allowing us a way to find areas of things that are not so nice, right? That have weird shapes to them. I wonder if this will help us figure out what the area of a circle is. Now, we all know the area of a circle. It's pi r squared, right? Someone gives you a circle, they give you the radius, everyone will say area is pi r squared. But that, yes, that's true, but that eluded us for a long time. The Chinese attacked that problem. They used the method of exhaustion. They came up with all these little approximations. I showed that to you. And they got some pretty good approximations for pi, too. 22/7 is a good approximation, but it's not pi. So it wasn't good enough. I wonder if today, on the 1st of, March 2016, we can use what we've learned to actually come up with that formula on our own. What would that require? Let's think about this picture. I want to know the area of a general circle. We know what the answer should be, but I want to know, with what you've learned in this class, if you can come up with that formula. Anyone have any recommendations? How do you mean? You want to cut it in half and look at just half the circle? Which half? You want to look at top half? Yeah, the top. Okay. Okay, so you're looking at maybe trying to just find the area of that and then doubling that answer? Yeah, I think that's a fair way to go. You want me to orient this thing like where this would be like the origin maybe, and that would be like the x-axis here and the y-axis here? You want to split it again? You could? Y'all want to split it again into a quarter? Okay, we'll split it here. All right, I'm up for that. So you're saying let's find the area of this. That if we could find the area of this, whatever this is, we just multiply that times 4, and that should be the area of a circle. Okay. Well, I'm on board. Now what? It's a good suggestion. Okay, the integral, it's going to be an integral. Hopefully you see that. It's an integral, right? It's the area. And you said 0 to r. Very good. We're going to go 0 to r because we know that the x value is going to have to range from 0 to r, isn't it? This is an arbitrary circle. The radius is r. Okay, good. Now, what? We need a function. Do you know the function that draws the circle? Do you know, okay, yes. Do you know any equation that gives you a circle?
Is it x squared?
X squared, keep going, plus y squared, that's the unit circle. No, you're so close.
42.
Is it a letter?
R squared. R squared. X squared plus y squared equals r squared. That is the general formula of a circle that is centered at the origin with a radius of r. That actually comes from a more general formula that you've hopefully, now that you've seen this, remember. This is the more general form of a circle. This is a circle with radius r and center hk. So of course, if we're going to want to orient this circle in the center of our grid, right, at 0, 0, then h and k are 0, and it becomes x squared plus y squared equals r squared. This is the one everyone should remember. That's just one special case. Hey, I'm good. The only problem I have with this so far is that right there is not a function of x. Because circles fail the vertical line test, don't they? So that's not a function of x. Yeah, the way we know that is if we tried to solve for y here. Let's try and solve for y real quick. If we try and solve for y, we would get y squared equals r squared minus x squared, wouldn't we? And then if you try and get y right now, I'm going to have to do plus or minus the square root of r squared minus x squared, yeah? So what happens here is if I do the plus, that's going to draw me the top half of the circle. If I do the minus, it's going to draw me the bottom half. And the reason we know that is because this answers the y coordinate, isn't it? So if it's positive, then it's the top. If it's negative, then the y's are below. Make sense? So really, if we're looking at this piece, we're at the top, right? So we can look at the positive, right? We don't need to worry about the negative. So what is the function that we need to integrate? Square root r squared. Oh. How are you going to integrate that? Trig sub. That's a trig sub. It's not arc sine. I don't know if that's what we're saying. If it's 1 over. Oh, yes, yeah, okay, yes. So we can do this with trig sub, couldn't we? Let's do it. What's the trig sub if we have, the variable here for us is what letter? No. Well, okay. X is the variable. X is the variable. R is the A, isn't it?
Yes.
R is really the A. So the appropriate trig substitution for this is x equals a sine theta, which for us is really r sine theta. Remember that r is a fixed number, right? R is fixed. And then we go through and we say dx is r cosine theta d theta. And then the square root part of this is r squared minus x squared equals, what is it? R cosine theta? We've done this before. And now I go rewrite the integral. What does this integral turn into? Integral from 0 to r. You know what? Let's do this. Take these off because we're just going to find the antiderivative first. Okay? Let's just find the antiderivative first. So we're integrating this. We'll come back to the definite integral after we're done with our integration. This turns into the integral, what was it? R cosine theta times r cosine theta again? D theta. Good. And that's just...
R cosine theta squared.
So we can square the r and the theta, can't we?
Right.
R is a constant. Pull it out of the integral. R squared, that's very promising. Cosine squared theta, d theta, right? And how do you integrate cosine squared theta, d theta? Power reducing. Good. 1/2. So this is going to be r squared integral. You said this is going to turn into 1/2. Can I pull that out?
Yes.
1/2, and then it's two things now, right? 1 plus cosine 2 theta d theta. Now, find the antiderivative of each of those. Term by term. So I've got, let me write r squared over 2 out front instead of that. Antiderivative of 1 theta